All right, moving along with chapter 2, we're moving to distributive property 2.2. Your learning target today, you can use distributive property to simplify numerical and algebraic expressions. So, vocab you need to know is distribute, and I'm going to use that vocab in the actual meaning. To distribute out in math, we multiply. So to distribute out in math, I'm telling you to multiply terms together. So to distribute out in math, we multiply. The steps for distributing, the first thing we do is multiply the first term by what's outside the parentheses. Secondly, we multiply the second term by the same number and simplify if needed. So we use this a lot with doing mental math, which is an upcoming slide, but this is the same kind of expression. When it's all numerical, you don't see it too much. This is just going to be 6 times 30 plus 6 times 4, 180 plus 24, which is 204. A lot of the times as 7th and 8th graders and high schoolers, we see distribution not in the numerical sense, but having variables inside there. That's the most common form. 7 times 20 plus 3. Distributing the 7, it's 7 times 20 plus 7 times 3. 7 times 2 is 14, add the 0, plus 21, which is 161. Another example, 30 plus 20 plus 5, or 3 times 20 plus 5. Distributing the 3 out, you get 60 plus 15, which is 75. Now notice how I just kind of congested it. I'm not showing as much as of my work. This is totally acceptable for you to do. All right, you can jump right to the distribution part. That's fine. I know this line and this line and this line tells me that you know what you're doing, okay? But I do want to see the distribution. Next page, move to some algebraic examples. Remember when we multiply a number with a variable, you just stick the variable to the side. Don't worry about putting parentheses or a dot or an x for times. You just stick the variable next to it. So we're going to go 3 times x, which is just 3x, plus 3 times 2, which is 6. Leaving it as is because they are not like terms, so you cannot connect them. It is not 9x. Variable on the right-hand side, they like to do that to try to confuse you. Anytime I see a number sticking to parentheses, I'm like, oh, I need to distribute. And that's what you should be thinking. So I see this number sticking, 3 sticking to the parentheses, I need to distribute. 3 times x is 3x, plus 3 times 4 is 12. Next example, 7. Distribute it out. 7 times 2 is 14, put the x, plus 7 times 1 is 7. 7x minus 5, same strategy. 7 times x is 7x, minus, because there's a minus inside there, 7 times 5 is 35. Nine times the difference of 4 and x. 9 times 4 is 36, minus 9 times x is 9x. Proper math etiquette would not leave it like this. Okay, you always want the variable first, always. Okay, and you guys definitely, I need you to have your variable first. So, subtraction isn't commutative, but I can turn my subtraction into addition. Now I can flip numbers around. This turns into negative 9x plus 36. That's the technical best choice for an answer. This one would work I would not count you wrong, but I strongly encourage you to put the variable first, the variable term first. Next, distributive property for mental math. This is real world application right here. I use this all the time at my part-time job at the gas station. I constantly am using the distributive property and breaking numbers up because people have coupons for like 7 cents off a gallon, and if they have like 23 gallons, I go 7 times 2 is $1.40 plus the 21 would be 161 off or something like that. So what you want to do is break the numbers into their place values. And then you add. You'll add them up at the end. That's called expanded notation. You did this a lot in elementary, a little bit in 6th grade. It's kind of fun though once you get into it. So 7 times 23, you rewrite this as 7 times 20 plus 3. I have 2 10s, the 20, and this represents 3 1s. That's the place values. Now I can use distribution. 7 times 20 is 140, plus 7 times 3 is 21, which is 161. Much quicker to do that mentally in my head. 6 times 47. So I have 6 times, I have a 40, and I have a 7. Place values. Distribute it out. 6 times 40 is 240. Plus 6 times 7 is 42. Now I can quickly add it to 282. I want you to break the next one up and find the sum or product. All right, breaking 37 up, this turns into 4 times 30 plus 7. I have a 30 and I have a 7, right? That's when I break it up. So 4 times 30 is 120 plus 4 times 7 is 28. I can quickly add that to 148. 9 times 42, I have a 40 and I have a 2. So this turns into 9 times 40 plus 2. 9 times 40 is 360 plus 9 times 2 is 18, 378. So I'm hoping that looking at this and applying the distribution, you can see that it really is helpful. It's really helpful getting through products faster, being able to break that down. Next page, distributing a negative. Some of middle schoolers' worst enemy right here, the slide. We are not big fans of distributing negatives, but we're going to get through it. So, negative parentheses x minus 3 just means negative 1 times x minus 3. That is a 1 outside. This 1 loves to just hide. It likes to hide as often as possible, and I don't know why. The 1 doesn't show up until it absolutely needs to. We distribute this negative 1 to everything, and negative 1 times x would just be negative x. Minus negative 1 times 3, what's negative 1 times 3? Negative 3. This is not simplified. What can I do with minus and negative? Plus. You can plus it. This turns into negative x plus 3. Now I am done. So anytime you see 2 signs in the middle, at the end you need to turn it into 1. 2 signs in the middle, turn it into 1 at the end. Negative 1, this is a 1, times negative x plus 12. That's a 1 in front of the x. So negative 1 times negative 1 is what? 1, right? Just x, 1 times x, which would just be x. Plus, negative 1 times 12 is what? Negative 12. Now if I add a negative, what do you think that is? Is that adding or subtracting? Subtracting. So I rewrite this as x minus 12. Now I am done. It's fully simplified. Negative 4 minus 3x plus 4. These last two, I want you to just take a minute and try to complete them through yourself. Compare with somebody next to you, and we'll come back together in about 2 minutes. Okay, negative 4 times negative 3x plus 4. I'm distributing this negative 4 to the terms inside. Terms means parts. Negative 4 times negative 3 is a positive 12x. Plus, negative 4 times 4 is a negative 16. I do not leave it that way because I have two signs in the middle. It is not fully simplified. Turns into 12x minus 16. Okay? It kind of follows the same rule as addition or as multiplication and division, where if they're the same sign, you add. If they're different signs, you're actually subtracting. So here they're different signs, so it turned it into subtraction. If they're the same signs, it's like adding. All right, distributing this next one. Negative 2 times 6 is a negative 12x. Minus negative 2 times 8 is negative 16. I have two signs in the middle. They are the same, so what does that mean? Plus it. Negative 12x plus 16. All right. I added a slide to this that I just added it last night. I didn't include it on your note sheet. But I do want to expose it to you. Again, another thing that you might be assessed on is modeling. And the long green model represents x. This long one represents x. The yellow represents positive 1, and the red represents negative 1. Okay? So when it says use a model to multiply 3 times 2x plus 5, that just means we have this 2x plus 5 3 times. So I have 2 x's and 5 positives 3 times. Whoops, I put 6 positives. And that represents the 3 times 2x plus 5. Here's 1 time, 2 times, 3 times. Final answer, combine your x's. 1, 2, 3, 4, 5, 6. I have 6 here. I have 5, 10, 15 total. So it turns into 6x plus 15. And you might be, I think in a couple of your 2 problems, it asks you to utilize the model. And this example is on page 75, so if you need just a little refresher, you can look at that. Last page of today's notes is the enriched part where we are moving, this is actually 8th grade math, okay? But distribution can deal with fractions as well. So when I think of 2x plus 7 over 5, this actually, I can pull this 5 out and write it as 2x over 5 plus 7 over 5. Separating the numerator and denominator, or separating the numerators and putting them each over the denominator. That's writing that as a sum or difference. This gets us ready for graphing slope-intercept form, which you'll learn in chapter 8, I think it is. This next one, 8 minus 9x over 3, that says both of them are over 3. So I have 8 over 3, take away 9 over 3x. Oh, now I can do more. This 9 over 3 can be simplified, because I know what 9 over 3 is. 8/3 I just leave. I don't really know what else that is. But I do know that this turns into 3. And that's the purpose behind it. The purpose behind it is usually when you break things up, you'll have some form of